Welcome to The Explainer. Today, we're getting under the hood of something we've all experienced, but very few of us truly understand: the soul-crushing, mind-bending traffic jam. So let's start with a scene you probably know all too well. You're crawling along, just bumper to bumper, for what feels like an absolute eternity. Then, all of a sudden, it just clears up. No accident, no construction, nothing, and you're left thinking, what on earth just happened? Well, those are called phantom jams, and believe it or not, they are not random. They're the result of a single, powerful, and usually totally invisible force that governs the physics of our roads. To really solve this mystery, we can't just look at how many cars are on the road, or even how fast they're going. Turns out there's a hidden variable, a secret ingredient that changes everything. Okay, so let's dive into this core concept. It's the one number to rule them all, and it's called traffic density. So, put simply, density isn't about speed, it's about proximity. It's just a measure of how crowded the road is, how much space each car has around it. And, getting a handle on this one number is the key to unlocking the entire life cycle of a traffic jam. Think of density as a spectrum. On one end, you've got zero density. That's a beautiful, wide open road where you're free to hit the speed limit. But on the other extreme, you have what's called jam density. It's basically a parking lot, a complete standstill, with up to 250 vehicles packed into a single mile of road. Now, this is where it gets really interesting. The way speed and density interact creates three very distinct zones, or you could almost think of them as personalities of traffic flow. In this graph, it illustrates that relationship perfectly. See, over on the left, when density is low, speed is high. But as you move to the right, as more cars pack onto the road, the speed steadily drops until, wham, it hits zero. This curve right here, it's everything. So first up, we've got the free flow zone. With up to about 42 vehicles per mile, things are great. The road can handle all the cars, you've got room to change lanes. This is traffic as it's meant to be, smooth sailing. Then we hit the second zone, the tipping point. Now, between 42 and 67 vehicles per mile, the highway is actually at its absolute peak performance. It's moving the maximum number of cars it possibly can. It's amazing, but it's also incredibly fragile. The system is on a knife's edge. All it takes is one person tapping their brakes too hard, and that sends a shockwave backwards that can shatter the whole thing. And if you push just a little past that tipping point, say more than 67 vehicles per mile, the system breaks. Welcome to Zone 3, Gridlock. Demand has now officially outstripped capacity. And here's the paradox. Even though there are more cars on the road actually becomes less productive. Speeds plummet, and you're in what engineers call breakdown flow. Yep, you're in a jam. So how do we actually see and measure this invisible force? I mean, how do we know which zone a highway is in at any given moment? Well, the tech has come a really long way. Back in the day, they would literally fly airplanes with cameras to take pictures and then manually count the cars. Today, it's all electronic detectors in the road that count cars as they enter and leave a section, giving us a live readout. But here's the catch. These modern systems have to be unbelievably precise. They are super sensitive to any errors. In fact, get this. Let's say you have a 1-mile stretch of road, and in 1 hour, 4,000 cars enter and 4,000 cars leave. Now, if the entry detector undercounts by just 1%, and the exit detector overcounts by just 1%, well, things get really weird. You end up with a calculated density of negative 6.67 vehicles. That's right, a tiny error makes the math tell you there are negative cars on the road. It just goes to show you what an immense challenge getting this data right really is. Okay, so let's bring this all together. Let's answer the big question. Why does any of this science matter to you on your daily commute? It matters because density isn't just some number for academics. It's a diagnostic tool. Think of it like taking a city's blood pressure. By watching the density in real time, we can actually see when a highway is getting close to that critical tipping point before it breaks down. And that knowledge is power. It lets us do all sorts of smart things, like using ramp meters to control how many cars get on the highway to keep it out of that danger zone, or using variable speed limits to slow everyone down just a little bit, which prevents those shockwaves that cause the phantom jams we started with. It's all about managing density to keep traffic happy and free-flowing. So the next time you're out there on the road, whether you're cruising along or you're stuck in one of those frustrating phantom jams, you'll know about the invisible force of density at play. you'll know the road has a personality and that there are people working to keep it from having a total breakdown. Which, of course, leaves us with one final big question to think about.